Well, while we're waiting for the Naza to lock in, I think might be a little bit crooked here. Might have to straighten out this this post that I've put in here, but I think it should work. Well, we're going to test it out. We were waiting for our lights. I wanted to show you this. If you can find any of these gumdrop lenses, it's a big plastic lens. I have one extra one here, but it actually enhances the Naza light quite well so that you can see it in daylight more. And at night it's really, really bright. It'll shoot to the ground at about 3 or 4 feet, so you get a good idea of what your lights are doing there. Now, looks like we've got green and one red. But I wanted to show you this prop on the front, see what kind of jello we're going to get. I've had to tape both ends. There's actually a piece stuck on there. And not the most streamlined. I have to retape it. It hit the grass before when the copter wasn't working too well. But as far as flying goes, it's flying really well. The 650 kV motors are something that you have to consider on 3-cell, that there is a minimum voltage that will keep the aircraft hovering, and you have more volts being used to spin up to the RPM that you need. So with the larger props, the RPM will go down. But with the 1100 kV motors on here, the Emax, those are spinning probably a lot faster and a lot easier at low voltages than the 650 kV motors, which when the battery gets to below 3.8 per cell and under load probably around 3.4, 3.6, it will not maintain a hover evenly. It will start dropping off to one side or the other, depending on the demand of power to the motors, because it can't divide those volts out of the battery that's low across all of these motors and give them all high voltages to keep that RPM up. Now, that's something to consider if you're going to get into large motors, is that you're going to want to go 4-cell and 5-cell, and that's why people run those larger batteries with the large pancake motors. So the smaller motors, the 2218s,